Okay, in this video we're going to cover these topics, or we're going to try and cover these topics um, in this set of videos. And this is, we're going to be working from the same book we were working with last week. And this is, we're going back actually to chapter 3. So I want to go through some of the topics here. Some of this we've already studied before. It will be a kind of review, but some of it is not a review. So this is called writing software. Now I'm using a different version today of Visual Studio. I downloaded the free 2012 version of Visual Studio. Here it looks quite different. You can also download it. Express 2012 for Windows Desktop. So some of the things are a little different, but we should be able to work with it. So one of the forms that we're going to build is this one here, and it's going to allow us to explore different data types. So for example, a date data type. So we get something like that. Months sometimes are referred to by their number. So this would be June. We might want to be able to access the actual day name. It's called a date literal. Okay, so this is one form we're going to work on. Another form is just going to allow us to explore another type of data, another data type called a double. Okay, where double is of, you're allowed to use decimal points, and that can be a very large number. We're going to try this. So you can format a number, or you cannot. Let's get back to that again. So without formatting, you might get some long string like this, so you might want to format the number so that you get something more manageable like this. Okay, we can extract certain parts of a string. And we can do some replacing as well. Okay, so let's begin with the chapter. There's a little bit more theory in this chapter, less maybe interesting programming, but the concepts are quite interesting and important. So we're going to talk about this word algorithms, which is very important, but not very complicated, part of programming. And we've talked about variables already, but we'll review that. Data types, including integers, what are called floating point. I think we've talked about that. Strings and dates. As I said, we're going to talk about the scope of a variable, and a little bit about debugging and how computers store data in memory. So we're going to explore that a little bit. We've talked about a little bit of that in class already. Now in this book he makes a distinction between data and information, and he says information is sort of something that you might have on a piece of paper, but data is when you get it ready to put it into the computer. So maybe you have a bunch of thoughts in your mind and you write them down on paper, but you want to get them into the computer, then it becomes data. He says, for example, if you make a tally, which just means a bunch of numbers, and you put it in Excel, then you can use it. Then it's called data. Now in other discussions, actually kind of use the reverse definitions. Like in a course I teach in data mining, I would say that data is sort of more raw than information. But here he's saying that you start with information and you convert it into data. In my data mining class, I would actually use these words differently. But anyway, in this text, that's how he's using these words. So it's important to realize that not all the language is uniform throughout every subject. Okay, now I'm sure you've seen this word before, algorithm. And basically, I'm just going to say that it's a plan of action. So if you're going to do something, you might make a plan before you do it, and you could call that an algorithm. He says the base underpinning of all software is the algorithm. He says before you can write software to solve a problem, you have to break it down into a step-by-step description of how the problem is going to be solved. So you need to sort of break it down into smaller pieces, and as you do that, you create an algorithm. Another important idea is that an algorithm isn't part of the programming language itself. In other words, you make a plan on how to accomplish some task, and then you convert that plan into a program. So you have the plan, you can convert it into a program in Visual Basic, or you could use C or C# or Java, right? So you convert it into with a programming language into a program, but first you have just the plan itself. So he says an algorithm is independent of the programming language. So if you like, you can describe it yourself either as spoken language, or even with diagrams, or whatever helps you visualize the problem. So he says, imagine that you work for a wireless telephone company, and you need to produce bills based on calls that your customers make. So you need to make these bills. So what are the steps that you're going to have to take to produce these bills? So he says step 1 is that on the first day of the month, you need to produce a bill for each customer. So that's part of the algorithm, part of the plan. So after that, what should we write? So he says for each customer, you have to have a list of calls that the customer has made in the previous month. So this would be the step 2 in this algorithm for how to create these bills. So this would be something, if you were working in a company, you'd have to create this algorithm yourself. You'd have to say, okay, on the first day of the month, I need to produce a bill for each customer. Then you should, for each customer, you have to have a list of calls. Okay, so that would be the second step you would write down. Now you're going to have to determine the cost of each call. So how are you going to do that? You know the duration of each call and the time of day when the call was made. Based on this information, you can determine the cost of each call. So this is another step you're going to have to accomplish. Notice that none of this has to do with a programming language, right? This is just a list of steps, a plan, in order to accomplish your goal or to solve your problem. Okay, then he says the next thing is, for each bill, you total the cost of each call. In other words, you have to have a total for the cost of all the calls. Then they say, so that's the next thing. Then if a customer exceeds a preset time limit, you charge the customer a certain rate for each minute that exceeds the allotted time. So that's another step that you'd have to do, right? Because some customers have only a certain time limit, and if they go above that, you charge them more. So you have to figure out whether that happened or not. Notice again, this has nothing to do with Visual Basic, nothing to do with a programming language. It's just a plan. Okay, the next thing he says is you have to apply sales tax to each bill. And then after you have the final bill, you need to print it and mail it. So these are steps, and this is an algorithm for solving the problem of producing a telephone bill. He says these 7 steps describe fairly completely an algorithm for a piece of software. So you'd want to convert this to a piece of software that generates bills for a wireless telephone company for outgoing calls made by a customer. At the end of the day, it doesn't matter whether you build this solution with C++ or with Visual Basic 2010 or with C# or Java, the basic algorithms of the software never change. So the plan is still there. How you implement the plan with a particular language might be somewhat different, but the plan is the same. However, it's important to realize that each of those 7 parts of the algorithm may well be made up of smaller, more detailed algorithms. So for each of these, you might have another algorithm that accomplishes each one of these.